Hello, welcome to the Geotechnical Engineering Part 1 Index Properties, Relationship and Test. Today we will be discussing about fundamental relationships, void ratio and porosity, degree of saturation, water content and specific gravity, dry density and saturated density, dry density and bulk density, relative density, some of the equations and numericals. We all know now the three-phase diagram of the soil. Solids, water and air are present. We also know the total volume of three-phase diagram and weight of soil in three-phase diagram. Relationship between the porosity and void ratio. We all know the porosity definition, volume of void to the total volume. Now what is total volume? Volume of air plus volume of water plus volume of solid. And we also know volume of void, that means volume of air plus volume of water. We have already seen this three-phase diagram. In the three-phase diagram, we all know porosity is volume of void to the total volume. Here total volume is substituted to volume of water, volume of void. Volume of void is volume of water plus volume of solid. We all know that. Here common terms, we are taking it out and then we are getting 1 divided by 1 bracket 1 plus 1 by E. Here using the LCM we get n equal to E divided by 1 plus E. Similarly we can get E porosity is equal to E divided by 1 plus E, and similarly void ratio is equal to porosity divided by 1 minus porosity, that is N. So now how void ratio and porosity relationship occurs. We all know the void ratio is volume of void to the volume of solid. Volume of void divided by total volume minus volume of void will gives you the volume of solid. Now here putting both sides, dividing it by total volume. Now volume of void to the total divided by total volume gives you the porosity. Now here common terms are cut, will gives you, or in denominator we will get 1 minus volume of void to the total volume. Now we all know volume of void to the total volume gives you N, that is porosity. So thus E equal to N divided by 1 minus N. Now let us take and assume the three-phase diagram where solid is 1 means 100% and other layer we are taking water it as a water and air voids, that is E, and water voids, that is EW, and total void will be 1 plus E. Using the above diagram we will be having a relationship. We all know the degree of saturation is volume of water divided by volume of void. From the above figure we have EW by E. Just we have discussed EW by E. So EW equal to E into SR. SR is the degree of saturation, E is the void, and EW is the void in water. Now other equation we also know, that is moisture content or water content is weight of water to the weight of solid. Converting the weight into density into volume. Now W equal to density of water to the volume of water divided by density of solid into volume of solid. Now converting the volume of water into EW and volume of solids as 1. Finally, we are also converting density of solids as we all know the degree G means specific gravity. Specific gravity is density of solid divided by density of water. So finally we are getting W equal to EW divided by G. So EW equal to G into W. So equating 1 and 2 we get that E equal to WG divided by SR. So this is the fundamental relationship between degree of saturation, water content and specific gravity. Now let us discuss about dry density and bulk density. To find this relationship, we have to go with the water content, weight of water divided by weight of dry soil, adding 1 on both sides. Then we are taking the LCM, WD plus WW divided by WD. Now WD plus WW is total weight. Now denominator terms are exchanged, then dividing it by volume on both sides, left side and right side, then rearranging to form dry density equal to bulk density, that is weight per volume, divided by 1 plus W. So this is the fundamental relationship, dry density equal to bulk density divided by 1 plus W. Again, using this same diagram, we will be calculating the fundamental relationship of dry density and saturated density. We all know the bulk density, that is weight per volume. Total weight is weight of solid plus weight of water. Now converting the weight into density into volume. Density of solid, volume of solid, density of water, volume of water. As per the diagram, we know volume of solid is 1 and volume of water is EW. And we also know that specific gravity is density of solid divided by density of water. So using this diagram and formula, we are getting bulk density as G plus E SR gamma W divided by 1 plus E. If degree of saturation is 0, that means it is a fully dry state. Then we are getting unit weight of dry unit weight, we say it as equal to G gamma W divided by 1 plus E. In saturated state means degree of saturation is fully 100%. We say it as unit weight of saturated soil gamma sat equal to G plus E gamma W 1 plus E. So depending upon degree of saturation, we will be getting the dry density and saturated density of soil. Relative density, ratio of difference of maximum void ratio and natural void ratio to the difference between the maximum void ratio and minimum void ratio. We say it as a relative density or density index. E max minus E divided by E max minus E minimum into 100. We'll be getting the relative density in percentage. If less than 15, very loose compaction. 15 to 35, loose. 35 to 65, medium. 65 to 85, dense. So based on the relative density, we'll be able to understand the soil is in loose state, medium state, dense state, or very dense state. So higher the relative density, higher will be the density. Here are some of the important equations to solve any numericals. Please go through these important equations for solving any numerical. So let us take one of the numerical. Here you can see soil sample have mass 600 gram, volume 400 cc. On drying, mass reduced by 50 gram, and specific gravity of soil is 2.7. Calculate moisture content and degree of saturation. So dry mass of soil will be 600 minus 50 will gives you 550 gram. Volume will be 400 cc. G will be 2.7 specific gravity. Density of water in gram, that is 1 gram per centimeter cube. We all know the formula, that is mass of water by mass of dry soil into 100 will gives you the moisture content. Degree of saturation also we all know, small wg equal to E into SR. So degree of saturation is moisture content into specific gravity divided by void ratio. So now we need void ratio first, because we don't have E value. So E is equal to G gamma W divided by gamma D minus 1 from the dry density equation. So using the bulk density, we will be getting the dry density and then putting the values of dry density, specific gravity and density of water will gives you the E value. Finally, we will be getting the degree of saturation as 25% approx. Here also undisturbed soil sample has total weight of 2060 gram, volume of 1200 cc, water content 11%, specific gravity 2.68%. We all need to compute void ratio, porosity, degree of saturation, water content to make fully saturated effective unit weight of soil sample. So here in this numerical, using the formula such as bulk density, that is total weight divided by volume, then we'll be using dry density. We have bulk density divided by 1 plus W, and then we'll be getting the void ratio. So we all know the formula of void ratio, that is E equal to G gamma W divided by gamma D minus 1. Then we will be able to find the porosity, that is E divided by 1 plus E. Then we will be able to find degree of saturation, that is SE equal to WG. Then we will be able to find water content to make sample fully saturated, gamma D equal to G plus E SR gamma W divided by 1 plus E. Then we can find the unit weight of soil sample using the bulk density, that is saturated density divided by weight of water, will gives you the submerged density of any particle. Here also in numerical 3 we will be having a compacted soil at a bulk density of 2.15 gram per centimeter cube, water content 12%, specific gravity 2.65, estimate dry density, void ratio, degree of saturation, and air content. We all know the formula: dry density equal to bulk density divided by 1 plus W. Using the above equation, we will be having void ratio formula, that is G gamma W divided by gamma D minus 1. So using the void ratio, we also will get the degree of saturation, SR, that is moisture content into specific gravity divided by void ratio. Then directly we will be getting the air content also, that is 1 minus degree of saturation. This is a small numerical showing the relative density of soil. Here you can see the volume of sand, that is 1600 ml in natural state. Minimum void is given 1400 ml and maximum volume, that is 2200 ml. So using the formula of density, that is dry density minus minimum dry density divided by maximum dry density minus minimum dry density into maximum dry density divided by dry density into 100. Using this formula, we will be getting the relative density of soil. So I request all the viewers to please solve the numerical using this hint. Thank you very much for listening.